Imagine, just for a second, the most absolutely catastrophic event possible for our planet. I'm not talking about an asteroid strike or a supervolcano, but a fundamental breakdown of the very physics that govern our lives. In this explainer, we're exploring a genuinely terrifying thought experiment. We call it the chronological doomsday. What would actually happen to the oceans, the climate, and, well, to us, if the Earth suddenly just stood still?
It's a pretty simple question, right? But the physics behind the answer are incredibly complex. We take the rotation of our planet entirely for granted. I mean, it gives us our 24-hour day, it shapes our weather patterns, and it even dictates the very shape of the oceans. To truly understand the powerful forces constantly at work around us, we really need to picture the exact second that those forces abruptly halt.
To wrap our heads around the immediate destruction, you first have to grasp this staggering number. Right now, as you sit there at the equator, the Earth is spinning at roughly 1,000 miles per hour. That's about 1,670 kilometers per hour. You don't feel it, of course, because you, the atmosphere, the oceans, and the buildings outside are all moving at that exact same constant velocity. It's kind of like sitting in a perfectly smooth airplane. You don't actually feel the speed at all until the brakes are slammed. Okay, let's dive into this. The key to this initial total destruction lies in Newton's first law of motion, inertia. If the bedrock of the Earth suddenly locks into place, the atmosphere, and literally everything not physically bolted deep down into the crust, doesn't just stop. No, it keeps moving eastward at 1,000 miles per hour. People, trees, topsoil, entire buildings, they would instantly be violently swept away parallel to the surface of the Earth. The sequence of events triggered by this sudden halt is a completely terrifying timeline. At 1 second in, we have that immediate destruction from inertia. Supersonic winds scour the planet, just completely flattening everything in their path. Fast forward 1 hour, and the inertia of the world's oceans takes over, sending unimaginable, colossal tsunamis crashing miles inland. And hey, if anything were to somehow miraculously survive that, fast forward 6 months, and those survivors would face a totally unrecognizable climate and extreme lethal seasonal shifts. Now, once that initial violent momentum finally settles down, if you can even picture that, the long-term geophysical nightmare begins. You see, a stationary Earth means the fundamental shape of our world changes. The line separating oceans from continents, what we call sea level, is actually this highly delicate balancing act between the Earth's gravity pulling water inward and an opposing force pushing it outward. That opposing force is centrifugal force. Because the Earth is spinning, it literally throws water outward toward the equator, creating what we call the equatorial bulge. This is an actual 8-kilometer-high accumulation of ocean water right around the middle of our planet. Our Earth is technically an ellipsoid, a slightly flattened sphere, specifically because of this spin. But without rotation, that outward centrifugal force simply vanishes into thin air. Let's move to and see how this builds, because the step-by-step reality here is wild. Step 1, the rotation stops. Step 2, without the spin, that 8-kilometer-high bulge of water has absolutely nothing holding it at the equator anymore. Step 3, gravity becomes the absolute boss. Gravity is actually strongest at the poles because they're slightly closer to the Earth's center of mass. So the world's oceans begin this massive, unstoppable migration away from the equator and straight toward the north and south poles. Step 4. This massive draining of the equator reveals a brand new global geography. Just think about how profoundly different this new map of Earth becomes. As all that water rushes north, the flat plains of Siberia and northern Canada are entirely submerged. Down in the south, despite its really high elevation, Antarctica is completely swallowed by the rising polar ocean. Meanwhile, an unimaginably vast equatorial megacontinent forms, joining the Americas, Africa, and Asia into one giant continuous landmass. And get this, the new global divide separating these two giant polar oceans wouldn't even be Mount Everest. It would peak at 12,280 meters high, right in the Colombian Andes.
So we have this newly drawn map. But what would it actually be like to stand on that megacontinent? Well, the answer lies in the sky. Remember, the Earth has stopped spinning on its axis, but it's still revolving around the sun. That means the length of a year remains exactly the same, but the length of a single day? That now stretches out to last an entire year.
And this brilliantly illustrates the terrifying new reality. You are now trapped between two completely apocalyptic environments. The side of the Earth facing the sun endures 6 straight months of continuous, boiling daylight, likely baking that massive new equatorial continent into an absolute barren desert. Meanwhile, the dark side is plunged into 6 months of perpetual, frigid night, causing whatever water remains to freeze solid. You would literally have to constantly migrate along the twilight zone just to experience survivable temperatures.
And trust me, the atmosphere is not handling this extreme temperature gradient well at all. The massive difference in heat between the blazing sun side and the freezing dark side creates chaotic, entirely unpredictable global storms. Furthermore, the Coriolis effect, that's the phenomenon caused by Earth's spin that naturally curves winds and creates our predictable weather systems, well, that completely disappears. The trade winds, the jet streams, the ocean currents, all the systems that distribute heat and make our planet habitable just collapse entirely.
Now, as if the surface conditions weren't horrific enough, a slower, highly existential threat is emerging from deep within the silent core of our motionless planet. See, Earth is protected by an invisible magnetic shield that spans far out into space. But this shield requires constant mechanical energy to actually sustain itself.
So the crucial point is that our planet's magnetic field isn't just a permanent magnet sitting down there. It's an electromagnet generated by the geodynamo effect. The rapid spinning of the Earth constantly churns the molten iron and nickel in the outer core. This convection, combined with the rotation, creates powerful electric currents that project our magnetic field. A stationary Earth means this internal liquid engine gradually, but inevitably, grinds to a dead halt. And without that geodynamo churning away, we are totally exposed to the cosmos. As the magnetic field weakens and eventually vanishes, the Earth loses its primary defense against the sun. Deadly solar winds would begin to directly strike the surface. Over time, these relentless solar winds would physically strip away our atmosphere entirely, and harsh cosmic radiation would bombard the ground, making the surface completely lethal to any complex biology. Before we conclude our grim survival assessment here, I want to share a surprisingly fascinating piece of physics. Let's say you managed to survive the supersonic winds, the tsunamis, the freezing darkness, and the cosmic radiation. How would your own physical body feel on this stationary Earth? Well, without the outward centrifugal push of the Earth's spin actively working against gravity, you would actually feel heavier. According to calculations by NASA astrophysicists, a 154-pound person standing at the equator would suddenly weigh an extra 0.54 pounds. But unfortunately, noticing a half-pound weight gain would literally be the least of our worries. The ultimate question is, can anything survive this? All flora and fauna have biological clocks, circadian rhythms, tied directly to the 24-hour day. With that rhythm destroyed, photosynthesis halts, migration patterns fail, and the entire global food chain completely collapses. Complex terrestrial life, including us humans, would face almost certain mass extinction. The only real survivors might be some resilient microorganisms living deep in the new polar oceans, completely insulated from the chaos happening above. Which leaves us with this final, genuinely haunting thought. We are inextricably linked to the motion of our planet. Its spin gives us the shape of our continents, the mildness of our seasons, the very air that we breathe, and the invisible magnetic shield that guards our lives. If it stopped, would life eventually find a way to adapt to a year-long day? Or would the Earth simply join the countless other barren rocks drifting silently through the cosmos? It's a stark reminder of the incredible, delicate balance that keeps us alive right now. Thanks for joining me on this thought experiment, and I'll see you in the next explainer.